Greetings, ladies and gentlemen. This is Mr. Jones just going over how to do the graphing quadratics assignment. So this packet is kind of fairly large. I think it has like 5-6 pages, something like that. And the way it's designed is so that as you go through the assignment, you discover things about how to graph quadratics. And we're just going to walk through a few of the parts. We're not going to do all of them because then you wouldn't be able to discover them. But let's kind of show you what it looks like. So first up, we're going to try graphing the function f of x equals x squared. And what that means is the y value, remember these are y's, is just equal to whatever the x is squared. And so here, if you do negative 3 squared, you're going to get 9. Because negative 3 times negative 3 is positive 9. And then negative 2 squared is 4, negative 1 squared is 1, 0 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And each one of these rows makes a point. This is the point, negative 2, 4. This one here is the point, 3, 9. And then we're going to come over here and graph those points. So I got the point negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And if you remember when we graphed these on the calculator earlier, they make this kind of U shape. So try and make it so it curves nicely. Don't turn it just into a V, because that actually is a different kind of graph, which we're going to graph later. So yeah, it kind of has this U shape here. So this is your basic quadratic function graph, and it's called a parabola. And it's spelled like this. Parabola, or if you want to just smush it together, it's like parabola. And I'm okay with that. Before we get to what that's actually talking about there, it does ask you what is the domain and what is the range. Remember, domain of a function is the x's or the inputs. The range is the y's or the outputs. And it's not just like which ones are the inputs and which ones are the outputs, but what are the possible inputs and what are the possible outputs. So in this function, you may have noticed I put arrows on it. This can go left and right forever. And so my domain is just going to go from negative infinity to positive infinity. Put some parentheses around it. And then for my range, you have to think about what's the lowest y value on this. What's the lowest possible y value? And it's down here. And this point here is at 0, 0. And that means the lowest possible y value is 0. And since our arrows are going up on both sides, this is going to go up forever. So the highest y value is actually going to be infinity. And I can put a parenthesis on the infinity, but I'm going to put a square bracket on 0. And the reason we put that is because it actually hits 0. You put the parenthesis or the open bracket if you approach it, but you never actually reach it. And you can never reach infinity. And so that's why those are parentheticals, and this one's going to be this square bracket. And the next part, it asks you what is the vertex, and we've talked about that before. It's just the highest or lowest point, and this one is at 0, 0. So fill that in, 0, 0. And so this next couple parts here is you're supposed to grab a different color, which I'm going to use purple next. It's a fun color. And you're supposed to graph this guy. Well, remember, this is saying the y values is equal to the x value squared plus 2. So when I come over here to my table, I'm just going to fill it in. I want to square the number and then add 2. So negative 2 squared is 4, add 2, you get 6. Negative 1 squared plus 2 is 1 plus 2, which is going to be 3. And then you're going to get 2, 3, and 6. So I'm going to go back to my graph, and I'm going to graph those ones as well. It's okay if you don't have a different color. It'll be totally fine. It just makes it so you can see them differently. They're separate. But let's go ahead and graph these. Negative 2, 6, negative 1, 3, 0, 2, 1, 3, and then 2, 6. And then I got this U shape here. It goes like that. Okay. And I'm going to leave it to you to fill in the vertex, domain, and range. Let's go ahead and graph this other one. Let's use green this time. So this one, f of x is x squared minus 3. So we're going to do the x value squared, and then minus 3. Negative 2 squared is 4, minus 3 is 1. 1 squared is 1, minus 3 gives you negative 2. 0 squared minus 3 is negative 3. And then it'll be negative 2 and then 1. So I'm going to plot these points here. Negative 2, 1. Negative 1, negative 2. 0, negative 3. 1, negative 2, and then 2, 1. I'm going to erase this vertex here so I can see my graph better. I'm going to connect these up like this. Like so. So I got my graph there. So now we've done those, and I'm going to leave it to you to fill these things in. Remember, vertex is highest or lowest point. Domain's how far left and right it goes. You just kind of put parentheses around it. And the range is how far down and then how far up it goes. And if one of those, it actually reaches a value, which is pretty common on your range, you can put a square bracket. So anyway, we get to the bottom here, and it asks you, what is the effect of k on the equation? What does it do to your graph? Well, when we added 2 to our graph here, I'm going to switch to a more pointy like color, like red. When we added 2, for like my purple graph, it's actually the same as the blue one, but it's just up 2. If I were to, and since I have this fancy tool, I can do this. If I were to take this and just move it up 2, it would match up. And so what it does is it shifts it vertically. And this green one, this was f of x was x squared minus 3. Well, it's the same as the original one, just down 3. Put that back where it was. And so this k value is a vertical shift of k units. Meaning your graph's going to move up or down whatever the k value is. And so now that you've seen that, it kind of tells you what a part of your function does. The next page changes your function in a slightly different way. Instead of doing x squared plus 2, this one has x plus 2, and then you square it. It is a different order of operations, and it does something different to your graph. So if I were to do minus 4 plus 2 squared, well, negative 4 plus 2 is negative 2, and when you square that, you get 4. And then negative 3 plus 2 squared is going to be negative 1 squared, which is 1. Negative 2 plus 2 squared is 0 squared, so it's going to be 0. Negative 1 plus 2 squared is 1 squared, which is 1. And then 0 plus 2 squared is going to be 4. So now I have these points. I'm going to graph them. This is the point negative 4, 4, negative 3, 1. And come over here and graph. Let's see. Sorry. Negative 4, 4. Negative 3, 1. Negative 2, 0, 1, 1. And then 0, 4. So I have my graph over here. Trying to connect this up all nice and neat here. Well, this looks like it's the exact same graph. It's just moved left a couple spots here. And that's exactly what it is. So when you have this change inside, it's actually going to move your graph horizontally. This is a horizontal change. And I wanted to mention that it said x plus 2, but it moved the graph left 2. And that's something you definitely want to make note here. When you add inside the squaring part, it's going to move it left. And chances are, if you subtract inside, it's going to go the opposite direction. But I'm going to leave it to you to fill in the points and then graph it and see what happens. But it is, once you've done both those, you can see what effect h has on your graph. So go ahead and do that. You'll come here, and instead of adding or subtracting 2, you're going to times by 2, and it's going to change your graph differently. And then you got this last one where it does negative in front, and you can see what that does to your graph. What you should do is try those pages out. I think that's like 4 pages. Yeah, it's 4 pages. But they're pretty quick. You just fill in the table and you graph them. You see what happens, and you discover what happens. So that's going to be the end of this video. The next one's going to go over how to do the next things.